Okay. So, model paper 5, the diagram shows the electric field lines for positive point. Charge and nearby negative charge are equal in magnitude. Electric field strength at P, Q, and R, which respectively, which arrangement shows the correct relative field strength. So this question actually answered by Weng Yu, but Weng Yu is not here. So actually you have to see how the density of the lines. So how much the lines at that point. So P will be the highest lines over there. R will be the second, and Q will be the least. So answer will be B. B will be answer. If you have correct, you congratulations. You have correct. You have 1 marks over here. So number 2, the diagram shows the variation of electric field intensity of E with the distance D along the straight line of electric field. So the shaded area under the curve between M and N. So this is E and D. E times D. Where is it? What is it? E times D. So remember V equals to E over D. Right? E over V over D. Is it? Yeah. Okay. E equals to V over D. So V equals to E times D. So you can see that E times D over here is the area under the graph. So the answer would be A, the potential difference between M and N. Okay. Number 3, a charge capacitor is connected in series with a switch and resistor. A voltmeter high resistance is connected to across the capacitor, the which is closed, and the set of values of voltage V and time is obtained. Graph ln V and gain T. This ln is uh, actually you remember, right, the equation of charging and discharging. Charging, oh sorry, is V equals to V naught exponent negative T over CR, where CR is the time constant. Okay, if you ln both of them, you have ln V equals to uh, ln V naught uh, negative uh, T over CR. So if you compare with the Y equals to mx plus C, you have Y equals to mx plus C. So C is not there, right? Is it C there, or C is 2? C is 2. And you know that x will be the T will be the x. So M is actually the gradient of the graph. I put as M. This is Nikola Tesla. I don't record dating curi idea. Oh, okay. So M equals to CR. M gradient negative 1 over CR. Okay, so CR is equals to 1 over gradient. So gradient is, what is it? Negative 1 over 0 negative 2 equals to 10 second. Which is 2 divided by 20 minus 0. Okay, so answer will be 10 second needed. Okay, the time constant for the circuit is 10 second. Okay, so remember when you see ln V, actually they already change it into from exponential graph turn into a linear graph. Okay, so number 4, this is Kashika, right? Number 4, did Kashika the one
Yeah.
who answer? Yeah.
Yeah.
Okay, capacitor or capacitance 10 microfarad is charged by a constant current of 5 milliampere. If initially capacitor was uncharged, what is the time taken for the potential difference across the capacitor? Uh, I think you can use a two method by using the Q equals to Q naught E, the exponential graph, or either you can use this method. This method is method by Kishika, Q equals C over V, and then you change T equals to Q over L, QI. This is not I L, it's Q over I. Kishika, you you root L. So
Yeah.
this
It's,
is 6.67 times divided by 5. There you have, yeah, this is correct. Answer is correct, but remember this is Q over L, I, it's not L. Okay, number 5, a wire of length L, cross-sectional area has resistance R. If the resistivity of metal wire is rho, the electrical conductivity. So rho equals to RA over L. This is correct. So sigma is 1 over. This is actually the same symbol. This rho 1 over rho equals to L over RA. So sigma equals to L over RA. This is correct. Okay, this is answer for number 5 is B. B. Okay, this is correct. So number 6, two wires X and Y, each of the same length and the same material, are connected in parallel to the battery. The diameter of X is 1/3 of Y. What is fraction of current passes through X? Connected two wires of battery diameter. Oh, it says that there are two wires over here, and this is the second wire. Okay, fraction. So there will be a battery over here. This is a battery. Okay, what current passes through X? Okay, so rho is using R equals to rho L over A, correct? So L over A 1 over A, so D over 2 squared. For current PD R equals to 1 over L, hence L is direct proportional to D squared. So I over I2, okay, this is correct because it's 1 over 3. Okay, and D squared, so this is 1 over 9. Oh yeah, it's 1 over 9. So L I2 over 1 I1 plus I2 equals 1 over 10. So this is 0.1. So this is D. This is correct. It's 0.1. Okay, Shika, you did it by yourself.
Yes, sir.
Okay. So number 6, number 7. So we have here the diagram show this is Y kit. This is Y kit answer. The diagram shows circuit where X, Y, X and Y, okay, is a uniform wire. When the gamma 2 is connected at point P, point P going down, and then at the point Q, P and Q. Oh, okay, so P and Q. The balance length are 40 cm and 44. Balance length, it means that galvanometer shows a zero deflection. Okay, so the value of R is, so you have actually this part, actually the concept is this part, this V equals to this V. Okay, V up equals to V down there, and it means it seems that the wire, the potential drop by taken by that wire is same as 100 ohm. Okay, and this part later when it change the position of the gamma, this V is same as this V. It means that uh, the wire over the blue one, the wire, how much the resistance of that wire is equals to 100 plus R. Okay, 100 plus R, which we don't know how much is the R actually. Okay, so how to do this one? This will be R direct proportional to the L, R1 over R2, L1 over L2. So 100 divided by 100 plus R equals to 0.4. Yeah, in meter 0.044. Okay, so R equals to 10. Okay, R equals to 10. So value of R is, so value of R is 10 ohm. This is correct. Okay, number 8, terminal voltage of the battery observed to form when battery supplies to the current external resistor. What quantity is needed to calculate for the voltage? Okay, it says that when you have a battery, when you have a only battery, there will be only EMF over there. But when you connected to a resistor, to the circuit of the resistor, the EMF will be falls down when we say that this is a potential difference of the battery. Okay, so what quantities are needed to calculate the fall in voltage? How much the V drops down, okay, from E to V. So we know that E equals to V plus IR. Okay, so for in terminal voltage V, and that is E minus IR equals to V. Okay, so you just rearrange back the equation. E minus I equals to V. So this one equals to IR, because V is actually equals to IR. So IR is the current and the external resistance. This is the factors that uh, made the value of E drops to a certain value. Okay, number 9, a proton enters perpendicular to uniform electric field, another proton enters perpendicularly into uniform electric field. Okay, so one goes inside a electric field. This is electric field. One going inside a magnetic field. B magnetic field. I put magnetic FBF, magnetic field. So proton enters. What? How is a proton? Is proton influence the speed of the? Oh, running out of time. Okay. Influenced by the speed v of the proton. So if the proton enters a region where we have a electric field, okay, of course it was going to deflect by the electric field, but it was not depends on the on the speed of it. Okay, but when we enter to the proton enter to the region where we have a magnetic field, the speed of the proton will be determine how much the force of the force by the magnetic field. So the answer will be uh, number 9. Answer will be C. In electric field, it was not influenced by the velocity of the proton, but in magnetic field, it was directly proportional to the proton. Okay, so in the way another way to say that electric force E force is equal to QE, and in the magnetic field force equals to BQV. So you can see that V is inside the equation. Okay, so that is 7, 8 and 9. Okay, we go to number 10. Which of following graphs represent the dependence of magnetic flux B at the center of the coil even the number of turns and current remain unchanged? You know that it will be uh, B equals to U naught and I over 2 2 R. It's 2 R. It's not 2 pi R. 2 R. Okay, is it 2 pi R or 2 R? Not 2 pi R. I think it's 2 pi. It's not 2 R. 2 pi R. Okay, so B is direct proportional to 1 over R. So answer is B. Okay, answer is B. The diagram shows a positive charge moving uniform magnetic field at velocity v in positive z direction. So this is one axis, second axis, and goes here with the z in the third axis v. Okay, goes down there. Okay, this is v. Magnetic fields in the positive x direction. Positive x, so the magnetic field goes in this direction, the b. Okay, the magnetic force along will be where? So we use the this is a positive charge, so this to a circular coil. Yeah. Oh, yeah. It's a circular coil. It's not a solenoid. It's a circular coil. Yeah, it's 2R. Okay. Hmm. Or it's not circular coil. I think the 2 pi R u not over 2 pi is a single what you call that, single conductor, right? 2 pi R u not I over 2 pi R. Hmm. So uh, okay, goes back to number 11. The diagram shows okay, so B going there, so which this is a proton, so left hand rule is a proton I, left hand rule. So FBI, BI, where is it? FBV, V pointing here, B pointing there. So C, answer is C, yeah, going up. Right hand rule, FBI, B, your index finger pointing to the X, and the V, that is the Q is pointing towards you. So your thumb is pointing up, so it's a positive Y. So answer is C, positive Y direction. Okay, number 12. The rectangle coil with the with W and the length L moving at constant velocity throughout uniform magnetic field B, directed perpendicular to the V, is shown at the diagram. Okay, this is what is this? Or rectangle coil over here. A length L or a certain M moving velocity perpendicular. Oh, it's going to enter the region of the magnetic field. If the magnetic field is a confined region of wave of 3W, which graph shows the direction of induced EMF with resistance X. Okay, so we start with 12. No, so it going inside W. Oh, so this one will be the same as on the below. So when it's going, no EMF is induced when the coil is outside magnetic field, and when it's completely in the magnetic field, uh, going to okay. So you can see that it's either A or D, because you cannot have a magnetic flux, no EMF induced. There's no EMF induced at this part. See, this one and this one is away. It's not the answer already. And when it enter at 0.0 to W, okay, zero point 0 W, uh, so when we coin inside, it will be a negative. Okay, it will be negative. It's because it's opposing the current will be opposing the Lenz law, opposing the change of the magnetic field, the induced current. Okay, a change of the magnetic flux be opposed, so it will be negative over here. Okay, negative. This is not, because we have a line over here, so it's negative. And then at the enters going this side, before it exit the magnetic field region, it will be have a positive side. So I think the answer is D. Okay, so answer is D. You cannot have increase, and this is what going up, and then steadily we have a flux. At this point we don't have any flux, because there's no change of flux over there, so we cannot have any value. It should be 0 down here. Okay, uh, number 13. A flat circular coil of 100 turns, each of 0.050 meter, is placed with axis parallel to a uniform magnetic field. Flux density change steadily to 90 to 50 over a period of 5 seconds. What if EMF induced of the coil during the time? So E equals to NA, the flux linkage, equals times with change of B divided by change of T. Okay, so it will be 100 times 0.005 times 90 minus 50, and this is in micro, a milli is a milli, divide that by 0.5, so you have 0.04 volt, or we can say as 40 millivolt. So answer will be A. In the circuit, alternating current RMS 1 ampere passes through a resistor in the steady current. So 14. So RMS current 1 ampere. If the two resistors, the value of R is okay. So RMS of 14, RMS of 1 ampere is the effective value of the AC current, and equals of the current 1.0A. So answer will be B. And number 15, E equals to negative L Ti over dt equals to negative Li cos omega t. So answer will be D. Okay, time's up. Okay, less than 1 minute. Okay, next time we continue with 16, 17 and 18, 19. Okay, thank you all. Time's up. It's
Thank you,
less
sir.
than 1 minute.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir. Thank you,
Bye,
sir.
sir. Thank you, sir.